Hello students. In this video lecture I am going to explain the concept of operator overloading. So the first thing is that operator overloading is one of the concepts of object oriented programming, which is polymorphism. So in C++, polymorphism can be implemented in two different ways. One we have already discussed, which is function overloading. So under function overloading we write the same function with the different functionalities. That is, the name of the function will be same, and we can give different functionalities to the name by changing the parameters. Now we will be learning about operator overloading, where the same operator can perform different activities based on the operands. So function overloading is done based on arguments, whereas operator overloading is done based on operands. So when the operator is used for usual operands like integers or characters or float, that is all the built-in data types, then it will do the built-in task, whatever the arithmetic operation it is supposed to perform, it will do it as usual. But when we overload the operators for class objects and use the objects as operands, then it will behave according to how we determine. So we will have to decide what the operator has to do, and we have to write the code for that so that it will do exactly what we say. So we will be learning about how to create our own function for operator overloading so that it executes that function when we use the operator with our objects. We already had seen that function overloading and operator overloading are very similar, except that in function overloading arguments are involved for for differentiating the different versions of a function, whereas here operands are playing the role of differentiating the operators for different roles. Even though we are going to learn about how to overload operators, we already have example of operator overloading in C++. For example, when we use the operator plus with integer operands like a plus b, it will perform the arithmetic operation. The value of a and the value of b will be added, and the result will be assigned to the variable in the left side. Whereas when we use the same plus operator in the middle of two string operands, then it will behave as a concatenation operator. So it's not going to be acting as an arithmetic operator, but it will be acting as a concatenation operator. So this overloading is made part of the C++, so we can make use of the plus operator in both the situations. This is an example of operator overloading. The same operator behaves differently according to the operand. Now we are going to focus on how to overload the operators for our objects, because the objects that we develop or create in our class, in our program, are completely new. So the compiler don't have any knowledge about our objects. So we have to create that knowledge. We have a concept called machine learning, which is more about making the machine to learn about something new. Similarly, this is a smaller variant of that. So we are going to give that knowledge of how to manipulate objects using operators by writing our own coding. So for example, there are four different statements involving the objects and operands. The first statement is obj3 equal to obj1. In this case, we don't need to do anything because the compiler automatically has that overloading. So just like it can assign an integer variable to another integer variable, it can also deal with the object assignment. So it will copy the content of object 1 into object 3. This is overloading already taken care, so we don't need to write coding for that. Whereas when you try to use the other operators like plus operator, we can't add two objects and assign result to a third object. So we have to create that intelligence into the program. Similarly, we can't use comparison operator, plus plus, minus minus, less than, most of the operators won't be working with the objects. So we have to make them work. That is our goal. So if I develop the overloading of plus operator, then I will be able to perform this task. So when I say obj3 equal to obj1, the value of obj1 will be added with the values of obj2 and C will be having the resultant value. Similarly, these are all examples of operators used with objects but won't work unless we write the code for them. That is our task of operator overloading. Here is an error message. Okay, if you try using the operators for objects, what will happen in the program? This message says that no match for operator plus with the operands of type object and object. So it says that when you are using plus operator with your own objects, I have no idea how to deal with that. So we have an error message clearly saying that the operator doesn't work with the objects that we create. The concept of operator overloading is very important in C++ because it allows us to evolve an operator. Just like we can overload functions, so operators can also be given additional tasks. Now the next question is that then how to overload operators. So operator overloading is important and is also very helpful, but then how to implement it? The implementation requires to follow few steps. The first step is that we need to develop something called as a operator function. So for every operator overloading, there should be a suitable operator function. Only then we can overload. So whenever we invoke that operator in the main function, it will look for the operator function appropriate for that. If it finds the operator function, it will just execute that function and the operator will get completed. But if the operator function is missing in the program, then you will just get the error message like this. So we have to follow the syntax of the operator function, which we will see shortly. And when it comes to the implementation of operator function, we are given two choices. One is to implement it as a member function, like we have implemented a lot of member functions in classes. We can also implement the operator function as one more member function, like a constructor, like a member function. The operator function will also be a member function of a class. The second option is a friend function. As we discussed earlier, a friend function is a non-member function of a class. It's not part of the class, but still it is allowed to access the private members. So we will discuss about the implementation of friend function based operator overloading later. Initially we will focus on the member function based implementation, because most of the operators can be implemented successfully with the member function itself. Only very few require to go for the friend function. So we will deal with the member function implementation now. But there are few operators which can never be overloaded. These are excluded. So this list has all the operators which are impossible to overload. So we should not try to overload any one of these operators. But as we can see, there are only very few operators which are excluded, which means most of the operators can be overloaded by writing the code. And we also have to follow certain rules for during the operator overloading. The first rule is that out of the two operands, at least one of them have to be a class object. In case if it is a binary operator, then it will require two operands. And it's necessary that at least one of the operand must be a object. Otherwise, it is going to it is meaningless to treat it as operator overloading. And we cannot create any new operator for the purpose of overloading. So we have the list of operators already existing, and we can choose any of those operators and overload them. And we have already seen that there is no way to overload some of the operators. And out of the choices of member function based and friend function based overloading, some operators cannot be overloaded using friend function. So these are the operators. For example, assignment operator can be overloaded only through a member function, not through a friend function. So we have to keep in mind all these restrictions while we go for operator overloading. And as I told you, we are going to deal with the member function based implementation. So the syntax of the function we are going to write for the operator overloading will have these details. First one is the return type. So the return type of a operator function can be anything as per the requirement. It can be a void, or it can be returning an object, or it can be returning a basic data type, integer, character, or float. So this is not fixed. There is no syntax rule which says that you should return only a particular type. It is completely left to the choice of the programmer. So we can decide what needs to be the return value. And the second part is the name of the class. The class name is needed only if the function is defined outside the class. As we have already seen, you can define a member function in two ways. Either completely inside the class, or declare it in the class and then define it outside the class. This syntax indicates the definition of the function outside the class. Class name, scope resolution, and next is the keyword called operator. So the operator keyword is immediately followed by the actual operator we are going to, or we are trying to overload, without any space. Keep in mind that operator is immediately followed by the specific operator, which can be plus, minus, subtraction, greater than, less than, or even assignment operator. Whatever we want to overload, that has to be filled in this place of the hash symbol. And the argument list, the argument list is fixed, unlike the return type where it's completely open, but the argument list is fixed based on certain aspects. We will see that in the coming slide. And we have to write the operations. So what we want to perform as part of the operator overloading function, which is our own choice. So even though the return type is left to the programmer, most of the cases we will try to return a class object. The requirement of operator function's return type is usually an object, but it can be void as well as basic data type also. So here are some examples how to decide the return type. For example, in the first usage, I am trying to overload the plus operator as obj1 plus obj2. Since I am not trying to assign the result to any object, there is no left hand side object in the expression. This has to be treated as a void function. Whereas in the second case, I add the two objects and the resultant object needs to be assigned to the left side. So in this case, this should return. Here the operator function is supposed to return an object. Otherwise, it will lead to an error message. In the third case, I am adding the two objects and I need to return some integer value. So the operator function for this particular statement has to be defined with the return type as integer. So this is the way we decide about the return type of an operator function. It depends upon the usage in the main function. How do we use an operator in the main function? Accordingly, we have to define the operator function. And now coming to the arguments. So the arguments are fixed based on two parameters. One is whether the operator is a binary operator or a unary operator, and secondly whether it's a member function or a friend function. So if you are overloading a unary operator and as a member function, it will take no parameters. So for a unary operator, there are no parameters because it only has one operand. Binary operator requires two operands. In that case, one object will be invoking object and the second object will be treated as a parameter. So for a binary binary operator which is overloaded using a member function, one argument is needed. Whereas if you are overloading a unary operator using a friend function, then it will take one argument. Whereas a binary operator using a friend function will take two arguments. So in simple words, when you overload an operator using a friend function, it will take one argument additional to the member function implementation. So if you are overloading plus plus as a member function, then the list argument is 0. If you are overloading plus plus as a friend function, then it will take one argument. So this is what we have to follow, and that has been summarized here. So operator overloading as for a unary operator, member function means one argument, which is I think it's wrong. For a member function there are no arguments, but for a friend function it takes one argument. And for a binary operator, actually the member function needs one argument, and for friend function it takes two arguments. So what has been mentioned here is not the correct one. So for a unary operator, member function takes 0 argument, whereas a friend function takes 1 argument. Whereas for binary operator, the member function takes 1 and friend takes 2. So we just add 1. So here 0, 1, 1, 2. And similarly, the return type, as we had seen, we can either return an object or a basic data type or return nothing, void. And when it comes to returning an object, we will see later that we can return either a named object or a nameless object. There is a slight difference between the two. We will see with the actual example. Now first we will focus on overloading a unary operator, then we will move on to the binary operator. So unary operators are comparatively easier to overload because we have to deal with only one object at a time. So it's and also when you are overloading using a friend member function, it won't even require an operand, argument. So it is going to be easier. Now this is what I am trying to achieve. So when I overload the plus plus operator for an object, let us assume that the object contains two variables as a and b. After I execute plus plus obj, I want the values of a and b to be incremented by 1. So a should become 6 and b should become 7. This should be achieved by overloading the plus plus operator appropriately inside my class. So let us see how we can write the coding for that. So first we will see a simple mechanism function which is based on a normal member function. So we are not going to immediately get into the operator overloading function. Let us see how it can be done with the existing knowledge. We already know how to write a member function. So we try to reach that goal by using a member function. So I am going to add a function called the increment, into which I write the statement for incrementing a and b as a plus plus b plus plus. And at the main function, I make an explicit call to the increment function and the values are getting incremented. So we already know how to write this kind of a program and it works. And we should keep in mind that when you write obj dot increment, the obj is the invoking object, the object which makes the call to the function. As a result, when you say a plus plus and b plus plus inside that function, you are indirectly referring to obj.a and obj.b. So whichever is the invoking object, its members will be manipulated by the function. That point you have to keep in mind, which is needed for our operator overloading. And so what is the drawback in this approach is that it looks very unnatural. That is, we need to write a separate function and remember that function name and have to mention it properly. Whereas this syntax looks more familiar. So anybody who see this understands that we are trying to increment obj. So this is the benefit of operator overloading. Our program will look natural and will look without any difference between basic data type and objects. So just like we use basic data types for these operators, we can also use them for class objects. So that is the advantage. Now we will see the operator overloading based implementation. So first thing is I have replaced the increment function by a operator function following the syntax. So the return type is void because I am not going to return anything. I am just going to increment the values. And the keyword operator followed by the specific operator which I am overloading now plus plus. And I am incrementing the two values. After that, I am invoking the object for operator function using the syntax plus plus obj. So plus plus obj actually is a way of calling this function called operator plus plus. So you have to remember that this statement will be implemented or executed as obj dot operator plus plus. Even though it looks like an arithmetic statement, it's actually a function call. So we are invoking the member function using obj. And the result is same. So whether you are using an operator overloading function or a normal member function, we are not getting any different result. But the difference is only in the readability and clear it looks much clear to understand. That's the only benefit. So this is the point you have to remember. So the obj++ not at all any arithmetic statement, it's actually a function call. It means obj dot operator plus plus function, where obj is treated as a invoking object. And I'm just trying to use the same function for a post increment. So earlier I tried to invoke the function for plus plus obj, which is for pre increment. I'm just trying the same for obj++, but unfortunately it won't work, because the version of the operator function we provided only suitable for pre increment operator. Compiler will not see a match for obj++, because for post increment that operator function doesn't suit. It won't be matching. So compiler saying that I'm unable to find a function for this. So we have to now overload the post increment operator differently. The difference is that we have to pass an integer argument in order to overload the post increment operator. You can now see that I have provided two operator versions, one for pre increment, another for post. The only difference between the two versions is the argument. So the integer argument don't have any real meaning. Its only purpose is to tell the compiler that this version should be invoked for the post increment, whereas the one without integer argument should be invoked for the pre increment operator. That is the way to differentiate pre and post increment operators. The same way you can also overload the decrement operators. Both pre decrement and post decrement can be followed with the same syntax. So now we are able to make use of both versions of the overloading. So when I call plus plus obj1, it goes to the version without a integer argument, whereas when I call obj2 plus plus, it now goes to the second version which takes an integer argument. See, here I am trying to do something which is improper for a plus plus operator. Ideally plus plus operator should only be used for incrementing a value, but here I am trying to change the value to more than 1. But still the compiler will not have any issue with that, because for the compiler it only matters whether the syntax is properly followed, whether the return type is proper, whether the keyword is correctly mentioned. Those syntax it only matters for the compiler. What you do inside the function doesn't or the logic of the function, it's up to the programmer. So we can write anything in the operator function. So ideally we should use it properly, but even if you misuse it, compiler will not find any fault with that. So here I'm just using the same example, but now I want to assign the result to a left hand object. See, even though it's a binary operator, I still can assign, like we can do for an integer variable as int a equal to plus plus b. Now what will happen is that b will be incremented by 1 and the incremented value will be assigned to a. I am trying the same here, but it won't work, because now this operator function has been defined as a void function. So a void function does not return anything, and so we are trying to assign a void function's return value to a object or to a left hand object, which is incorrect syntax. So the compiler will not accept it. To make it work, we have to do something. We can do something like this. If you really want to achieve this, step 1 is you increment the object, and step 2 you assign it to the another object. So this is possible. Only we can't do it in the single statement, but we can separate them and manage to get the same result. But we can modify the operator function so that even with the single statement we can achieve it. I will just see how to modify the program for that. So here I just have modified the operator function. The first change is that I replace the void by the class, because I am going to return an object, because here the left hand side contains an object. So only if I return an object, it will suit here, it will match with the expression. So I have changed it into a class. And then since I need to return an object, I am creating an object. So I create a temporary object and then assign the result into the object as temp A equal to A, temp B equal to B. Now temp contains the incremented values. And finally I am returning temp. Now what will happen is that the temp will be I mean the obj2 equal to obj plus obj1 will result in invoking of that function, and subsequently the values will be passed to the will be accessed here. A plus and b plus plus is nothing but obj1 dot a plus plus and obj2 dot obj b dot b plus plus, because here the invoking object is obj, so by default this will refer to the invoking object, and after that it returns the temporary object, and that temporary object is what being assigned to obj2, and so the obj2 will have the incremented values. So here it's a slightly modified version of the operator function where we return an object by creating a temporary object and then pushing the result into that object and returning that temporary object which is getting assigned here. See, this version have got a different way of doing it, which is called the nameless temporary object. So in the previous example, I was creating an object just to hold the results temporarily. I have no real purpose for this class except that I need A and B to be temporarily stored. Only then I can return an object. I can't return A and B as integers. I need to return an object. So the purpose of this object is just for that. Instead of creating a specific object, we can go for something called a nameless object. I will show the code for that. So here I just modified the code. As usual, I am returning an object. The return type is same. But in the coding, I haven't created a temporary object. Instead, I am just passing the A and B as arguments to the constructor. So we just have a constructor in the class which takes 2 arguments. Now when I say return my class AB, the return statement will be executed after the constructor is executed. So it will wait. So first my class AB will be called. So the A and B will come here and the object will be constructed, and the constructed object will now put in this place of return statement. So this statement will then become return the nameless object. So the steps to be being followed is that first constructor is called with the incremented value of A and B. When a constructor is called, an object is created and that object is assigned with the values of A and B which are being passed from here. And after this, that object will replace the constructor. So this constructor statement will be replaced by the nameless object which is finally returned. And that returned object is what being assigned to obj2. So eventually obj2 equal to plus obj1 actually becomes obj2 equal to the nameless object. Now we are stepping into the overloading of binary operators. So if you have clearly understood the implementation of unary operator overloading, you just need to know the difference between the two. So here the difference is that number of arguments. As we have already seen, for a unary operator there are no arguments needed, but for a binary operator one argument is needed. For a unary operator we have a invoking object, and for a binary object also we have a invoking object. Now let us try to go into the examples. So I want to get this done. That is, when I say obj1 plus obj2, I want to this will result in a function call. So obj1 plus obj2 will actually result in a function call where obj1 will be treated as the invoking object and obj2 will be treated as the argument. So this is not said by us. We are not telling the compiler to treat obj1 as the invoking object and obj2 as the argument. It is done by default. So the compiler automatically considers out of the 2 operands, the first operand is always considered as the invoking and the second operand is always by default treated as the argument. So we have to just keep in the mind while we are writing the operator function. And here is the operator function for the plus operator. So it is definitely have to have a object as a argument, otherwise it will be an error. It will be getting an object which is nothing but the second operand. So obj2 is what we will be receiving under this object, and obj1 will be automatically available as an invoking object. So we don't need to mention any object name for the first AB because it refers to the object 1. It's only for the second object which is passed explicitly as an argument we have to associate with the object name. So obj.a and obj.b, and this actually means temp a equal to obj1.a and plus obj2.a. And as usual we create a temporary object and put the result into that, and we are returning. Once again we can replace this by a nameless object. So the same can be written using a nameless object, but the result will be no different. So we have just implemented a binary operator overloading for the plus operator. Let me repeat the points. So here we are this object is going to return an object. This operator function is going to return an object, so that we can make an assignment statement like this. So obj3 equal to obj1 plus obj2. In this case it requires a return value which is an object, whereas if you have implemented just obj1 plus obj2 without anything in the left side, then we can make it void. We have to make it void if there are no return objects. But for the purpose of this statement, I have defined a return type as class object, and operator followed by plus, and the argument is nothing but the second operand. The second operand is the argument. So here I am creating the temporary object and calculating the result and finally returning. Now when I execute the program for the statement of obj3 equal to obj1 plus obj2, the compiler will treat it as obj1 dot operator plus obj2. So obj1 is the one invoking that operator function, which means its members are accessed automatically. But for second operand, which is obj2, we need explicit reference using the name of the object. Another way of invoking that operator is directly calling the display function. So here what happens is that, see, in this case it returns a temporary object which is assigned into obj3, and then we are calling display. We are just avoiding that extra statement here by directly invoking display for the temporary object. So when the temporary object comes here, we call the display directly with the help of this. So there is no need of obj3 equal to obj1 plus obj2. It's also another way of using it. So for in this statement we are not requiring any return object, so we can make it void. But here in this in the particular example, what is the problem is that I have defined two different classes and creating object for the two classes. My class is one class for which I am creating object 1, whereas my class 2 is a different class for which I am creating another object. So when I try to use the plus operator between the objects of two different classes, it does not work. So what we have done is that we have overloaded the operator for a particular class. That means you can use the objects of that class for overloading. obj1 and obj2 must be objects of the same class. The operator overloading does not work between two objects of different classes. So for that we have to do something else. We will discuss that particular implementation later. As of now, it doesn't work. So finally we have to understand that an operator may return any type of value between void, class object and basic data type. It's completely the choice of the programmer or the need of the application which determines what needs to be returned. So hope you have understood the implementation of unary operator overloading and binary operator overloading. So we will see about other operators and friend function based overloading in later classes.